1.4 with the complex numbers in trig. We just left with a problem just identical to this, and now we're doing it again here. When I said you have an x's and y's all over the place in these problems, let's try to solve problems in positions. And by that I mean there's no way we can get an x and a y by itself. It's just not possible. So what we can do here is, why don't we solve in position? So I know that this, because it's in front, and this are going to go together. And I know that these two in the back end are also going to have to go together. And I know this because this has an I in it for an imaginary number, and so does this. So these two in the back have to go together, and these two right here in the front have to go together. So I set up this first equation to solve, and I set up that equation to solve. So I have my two equations to try to solve here. This one's simple. Minus 5x on both sides. So I have a negative 8 equals negative 3x. Divide by a negative 3. And I know that x equals 8/3. Over here, this one on this side might be a little trickier. So what I'm going to do is I'm going to divide by that I. Let's get rid of that I. I don't even want to think about it anymore. Too many variables. So this is the actual equation that I have. Now I'm going to take that negative through to both those. I'm going to get a 13y equals negative 2 plus y. So now I'm going to try to solve for y, and to do so I'm going to subtract a y to get all my y's on one side. So I get 12y equals negative 2, and I'm going to divide by 12 to get y by itself, and by doing that I have y equals negative 1/6 after I reduce it, and that is my answer for x and y. Okay, so
I hate broccoli.
So now this problem right here, I guess it's just simplifying, combining like terms. 4 times 2 is 8, and 4 times 5 is 20i. Then I got to take this negative through. It's a negative 3 and a positive 4i. So 8 minus 3 is 5. 20i plus 4i is 24i. So I guess here's another problem then. For example 6, try foiling this. 4 times 2 is 8. 4 times I is 4i. Negative 3i times 2 is negative 6i, and negative 3i times I is negative 3i squared. Right? 4 times 2 is 8. 4 times I is 4i. Negative 3i times 2 is negative 6i. Negative 3i times I is negative 3i squared. Combine my like terms, so I get 8 plus, that's a negative 2i minus 3i squared. Need to remember that I squared is negative 1, right? So negative 1 times negative 3 is a positive 3. 8 plus 3 is 11. So I actually have 11 minus 2i as my final answer. Alright, with this one, basically remember, this is a no-no. Do not just square two things and leave it at that. It means I have this parentheses twice, right? 3 minus 2i, 3 minus 2i. So let's FOIL. 3 times 3 is 9, which, let me just put it all down. There you go. 3 times 3 is 9. 3 times negative 2i is negative 6i. Negative 2i times 3 is negative 6i. Negative 2i times negative 2i is positive 4i squared. And when we combine our like terms, that's a negative 12i right there. That I know is negative 1, right? And 4 times negative 1 is negative 4. And 9 minus 4 is 5. So I have an I on the outside times 5 minus 12i. Now take that I through, so I get 5i and a negative 12i squared. And once again, I squared is negative 1. So negative 1 times negative 12 is positive 12. So if I was to rewrite it the right way, it would be 12 plus a 5i as my final answer. Alright, these can get kind of tricky. So what we need to remember is the formulas. We said I was square root of negative 1. We said I squared was negative 1. We said I cubed is a negative I. So we're trying to simplify this basically. The reason why I have this up here is because if you remember, I to the fourth equals 1. So what we're going to try to do is we're going to try to take out groupings of 4s because that's basically I to the 4th power is just 1. So 4 goes into 51 how many whole times? It goes in 12 times because 4 times 12 is 48, and you end up having 3 left over. So by that I mean we have 48 because they are in groupings of 4, and 3 i's left over because 48 plus 3 is 51. And this, the reason why I wrote it this way is I can write it as 4 to the 12th, because 4 times 12 is 48, and like we said, what is I to the 4th power? That's a 1. So 1, right? The 12th is like saying 1. So really, you have I cubed, and I cubed, we actually know we can rewrite that as a negative I as our answer, not negative 1. It's actually a negative I as our answer. So keep that in mind. It's actually a negative I that we want. A negative I, not a negative 1. I cubed is negative I. Remember that. Negative I is the answer there.
We saved the day! Wow, wait. Yo.
So conjugates. If you have A plus BI, the conjugate is A minus BI. Okay, so it's whatever the opposite is. A plus BI, so it's A minus BI. It's whatever the opposite. The conjugate does equal the opposite. They're the same thing. So example 8, 5 plus 7i, the conjugate would be 5 minus 7i. Example 9, 4i, the conjugate would be negative 4i. It's the opposites.
I'm a cop and you will respect my authority!
So, if you have the same thing, but one's addition and one's subtraction, the i's will cancel out. You're just going to be left with a 2a. If you didn't know the formula or the property, it doesn't matter. You can just look at it and see that. Just like this. 4 plus 4, oh, that's 8. 3i minus, oh, that's gone. Foiling, the middle terms cancel out. You're going to actually just be left with a number, and it's just whatever they are squared. The first number and the second number, just add them together, and you'll get your answer squared. But if you didn't remember that, you could just FOIL, and everything will cancel out, and you'll get an answer. So keep that in mind if you don't remember this. But 4 squared is 16. 3 squared is 9, so 16 plus 9 is 25 is your answer if you remember the formula. But if you don't, you can FOIL and substitute, and everything will work out right as rain for you. So, quotients of complex numbers, here's how it works. You cannot have a root on the bottom. You can't have fractions on the bottom. You can't have complex numbers on the bottom. So I'm trying to get rid of this complex number. So it's 9 plus 2i on the bottom. So I'm going to multiply by 9 minus 2i on both the top and the bottom. 1 times all that on top is just all that on top, and the bottom is 9 plus 2i times 9 minus 2i. 9 times 9 is 81, and remember the property 2 times 2 is 4, if you remember that property, so really we end up with 9 minus 2i over 85.
Chunky, extra thick for extra flavor.
So we'll try to finish up here with 1.4 in complex numbers when we come back.